And I believe we got up to slightly past here. Okay. So I'm going to go through question 13 again, just briefly, so that we can get the context that we need for the rest of the question. So the diagram shows part of a food web in a large lake. And then as we move down, we had some hints over here, and we had to fill them into the boxes A, B, C, and D based upon these information. So we've got algae, which are eaten by mosquito larvae and water fleas. So we filled that in over there. And then we have sticklebacks that eat water fleas and mosquito larvae. So that's over there. Then we have fish such as perch and pike eat sticklebacks, and pike and otters eat perch. So perch and pike eat sticklebacks, and pike and otters eat perch. So that is how we filled that in. So now we have to go on to question B. In some areas, otters have been introduced into lakes and rivers. Fishermen claim that this has affected the food web and spoiled their fishing. Explain how and why introducing otters could affect the number of fish in the lake. Okay. So here we need to go look at our food web over here. So otters eat perch. So let's just see, sticklebacks are small fish. Okay, so these are our three fish species. We've got sticklebacks, perch, and pike. So there used to be lots of perch, lots of pike, because they could both feed on sticklebacks, and the pike could feed on the perch. Now the otters come in and they are eating some of the perch, which means that there will now be less perch because the otters are eating it. So the perch is also eaten by the pike, but since there are less perch, the pike will have less food to eat. And so the pike will start to have to decrease their numbers, so there will be less pike. So the otters are eating perch, so there's less perch, and because there's less perch, there will be less pike. So now we just need to go write this in a nice way over here. So let's start with otters. Okay. So there we go. So now the next question says, Jamila draws a picture of the sun and the planets in the solar system. So she labeled the sun. Write down the names of the two planets nearest to the sun. So here you need to remember the order that the planet's coming. So there is a little mnemonic that people use, and it's my very excellent mother just gave us nachos, I believe, yes. So my very excellent mother just gave us nachos. So the M from my means this is Mercury. The V gives us this is Venus. Then we have Earth from excellent. Then we have Mars. So that's from mother. The J gives us Jupiter. The U gives us gave. I am confused. This is strange. I literally do this every day and now I suddenly don't get it. Okay, so exam anxiety happens to everyone, even teachers. Sorry, guys. Yes, Saturn. So it's not gave, this should be sent. Well, come on. Saturn, Uranus, and Neptune. Thank you so much, guys. Okay, so the names of the two planets nearest to the sun, we've got Mercury and Venus. Okay, next we see the sun because it is a source of light. Explain why we see the planets. The planets reflect. Okay. So, question 15 says, Sophia investigates electrical circuits. She measures the voltage across a lamp. So that is where she put her voltmeter. Here she's got a little bulb, there's a battery, and there's a test wire. Okay, so she has the length of the test wire and then the voltage. So we can see as the test wire's length goes up, our voltage is steadily going down. So let's go on to the next page. Complete the graph of Sophia's results by adding labels to both of the axes and plotting the points. The first three have been done for you. So let's add some labels. So firstly, on this side, this should be the thing that we are measuring. So that would be the voltage in V. So here we go. And here we should have the length of test wire in centimeters. Great. So now we need to go plot the 2 points that we have left. So if we go up to over here, the 2 points that are left is 40 and 0.28. So on our x-axis, that's the length of the wire, so that would be 40. And over here on our y-axis, we'd have 0.28. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. There's 5, 7, 8. So that is where our point would be. And our last point is 50 and 0.22. So we've got 50 and then 0.22 will be over there. There we go. So there's our last 2 points plotted. So one of the results does not fit the pattern. So let's go see. If we try and go draw a straight line through these, then you can see that those line up very nicely, but that one is just slightly off. So which result is anomalous, and what should Sophia do to check this result? So our anomalous result is the 30 centimeter long wire. And she should measure the result again, perhaps 3 times okay. So we want to be very scientifically accurate, so we try not to measure things just once. Okay, so that was that, and then we reach the end of the paper. I'm going to show you guys how an ammeter and a voltmeter works and how to connect them into a circuit. So let's first start with how an ammeter and a voltmeter works. So let me just go here, share. Here we go, great. So ammeters and voltmeters. Here we go. An ammeter measures current. So it has a wire going straight through it, and then it has a counter. So it will literally count the electrons going past and give that amount in amperes, which is a measure of the current. So the amount of electrons going past, we measure essentially in ampere. Okay, so since it has to count all of them, the current has to go through the ammeter. So it literally counts the electrons going past every second. And then it will essentially give us a number out, which we call ampere, which is essentially a measure that we use to see how much current is flowing. So how many electrons are going past, essentially. So since it has to count all of them, all of the electrons have to go through the ammeter. So we have to connect the ammeter in series. It has to be inside the main circuit of our circuit that we're testing. A voltmeter measures the potential difference. Okay, so it essentially measures how much work the electrons can do, so their energy. So it measures it over here, and then it'll see, okay, you've got this much energy, and then it'll measure it after it's gone through a specific point, and then it'll see, okay, this is how much energy you have lost, so you can still do this much energy now. And then it gives us the difference between these values. So it essentially takes this minus this, and that is what it gives us. So it is a measurement of the difference between the amount of work the electrons have to do before they go through that part of the circuit and after they have gone through it. So if we put our voltmeter over a battery, so let me just draw a quick circuit over here. So here we go. If we go put our voltmeter over here, right, then it measures the electrons coming from the battery, so over here, then it has to go through the whole circuit, and then it measures them again over here before it goes back to the battery. So if you put a voltmeter over the battery, you're essentially measuring how much work the electrons have to do throughout the whole circuit. If you put it over a specific component, it measures how much work the electrons have to do over the specific component. So it'll measure here before it reaches it, and then it'll measure here after it has reached it. So if we add in another light bulb over here, then our difference here will be here. It would measure the volts, essentially the amount of energy the electrons have left for the whole circuit, to do the whole circuit. Here it would only measure the amount of work the electrons have to do for this one light bulb. Okay, so since they just measure the difference between the energy levels, it has to go over an obstacle in the circuit. So here we have our desk, and here I've got a bunch of equipment. I have a multimeter here, and this is a fairly normal multimeter. You can get them in any kind of hardware store. And this is used to measure essentially all of the sorts of things that we can do here. So how a multimeter works is it's got two cables like this, and we have to connect them into a circuit. If it's an ammeter, it goes into the circuit, and if it's a voltmeter, we just use these 2 points to essentially put them at specific points in the circuit to measure the volts going over it. So if we want to measure our volts in a battery circuit, so a battery powered circuit, that means we need to look at the direct current, so the DC. So that would be that part there. So DCA means the DC ammeter, and there we've got DCV, which means DC voltmeter. If we are instead looking at electricity coming from the wall, from the mains, then we're looking at alternating current, not direct current. So that would be that part there, and it would be somewhere else. There's another part that measures the resistance. Okay, so you do not necessarily have to get these materials. I am showing you how these work. If you want to go do the experiments throughout the book, you are most welcome to. It would help a lot in learning science. You can go through the book without them. Okay, so I have some light bulbs and some springs here. The springs are just to help me connect things. They're essentially wires. So I've got a little light bulb over here that I can screw into a little light bulb holder like that. And then if I want to connect it, I can use these 2 little springs, and then I can place it in between them. So I would do that, and then I would do that. And then now I can use these 2 springs to connect my little cables with their crocodile clips. They've got little clips over there that can open and close. So I can connect them very easily just by doing that. So that's why I do that. So let's start. Let's first just build the very basic circuit. So we've got our battery over here, and I am connecting a crocodile clip to the side and to the side of the light bulb. And then I am connecting a crocodile clip to the side and to the side of the light bulb. Just moving that one out of the way. And now you will hopefully see the light bulb light up. There we go. Yay, my light bulb is working. Okay. So now, if I want to go measure the amperes, the amount of current flowing through it, I now need to take my multimeter and I need to go set it for measuring amperes. I think it's that setting is the correct one. I will show you how to know which setting is the correct one now. And then we need to connect it into our circuit. So I clamp my crocodile clip to it so that the current will go straight through. And now I can use this to connect it into the circuit. So I'm going to use another crocodile clip to connect it in nicely. So there the crocodile clip goes. And now if you see the circuit, it goes straight through the whole thing. So we've got a value over here on our multimeter. I don't know if it is in mirror writing over there. So it says 135.6 or so, or 136. There we go. So how we know whether it is a correct reading, we can essentially do this. You would start at the smallest reading it can take. So that would be the micro over there, means we're measuring microamps. Here we are measuring milliamps. So if we go a setting lower, you'd see that it flashed and then it just showed a 1. That means that this setting, we need to go a setting higher because the units that it's measuring in is too high. So there we go. That's where we're measuring here. So that is the ammeter. We connected it into the circuit. So if I expand these just slightly, you can see that we have some current coming from our battery, going through this cable, through the light, out through there, through the ammeter, and then back to the battery. Okay. So let's disconnect these so I can show you guys our voltmeter. So before I connect this in, if we want to measure the volts, we are going to be using the measurements over here. So we will start at the smallest one, and then we will move our way up. So I've got my two clips. And now I'm going to clip it in so that our light is shining. So now if I want to measure it over the light bulb, I will put the two ends on the opposite sides of the light bulb. So it just showed a 1. So we have to go a setting higher. So start again. It shows a 1. So go a setting higher. Okay, there we go. If you can see, it's showing a negative reading over there, which just means that I need to swap these around. And now I get a nice positive reading. So it says 2.19 thereabouts volts across this light bulb. Okay. If I do it across the battery, then let me just isolate these crocodile clips so you can see. I would put it against that crocodile clip there and this crocodile clip there, and then you can see the volts across the battery. Okay. So now I'm going to show you guys, oh, that light bulb is getting hot. What happens if we add in another light bulb? So here I've got another light bulb with some springs, and there it goes. So let's first just go connect the basic circuit. There we go, and there we go. Now both light bulbs are lighting up. So we can go measure the volts across both of them or across the battery. So if we measure our volts across the battery, like so, there we go, then we get 2.64 volts. Okay, now we can go measure it across each of the light bulbs individually. So here you can see it's about 1.06. So it was 2 volts, slightly more than 2 volts across the battery. So here you can see they're doing half the work of the 2 volts. And here, if we go connect it across there, let's get to touching it, then we do the other half of the work across there, more or less. Okay, so that is essentially it for today. It was just how to connect a multimeter into a circuit so that we can measure volts and amps. Okay, you don't need to get these materials. You can get them if you want. These light bulbs and things come from a school electricity kit that you can buy at various places.